Today we'll explore a useful algebra skill, writing linear functions from verbal descriptions. In this video, we'll learn how to take real-world scenarios and turn them into linear equations. Whether you're describing the cost of a service, the distance someone has traveled, or even how fast something is moving, knowing how to write these situations as linear functions will help you break down and solve problems more easily. By the end of this lesson, you'll feel confident creating equations from words and turning them into something much easier to work with. Let's dive in. Imagine you've just signed up for a gym membership that costs $30 per month, and you had to pay a one-time fee of $50 when you joined. How can we write a linear function that describes the total cost after a certain number of months? Let's break it down. First, let's define the variables. M represents the number of months you've been a member and C of M represents the total cost after M months. So, we want to find the total cost C of M as a function of the number of months M. Next, what's the monthly cost? That's the recurring part of the payment, $30 each month. So, the slope of our line, which represents the rate of change, is 30. Now, what did you pay initially when you signed up? That's the one-time sign-up fee of $50. This is our y-intercept, because it's the cost when m is equal to 0. Now, we can put everything together into the equation for the total cost. The general form of a linear function is c of m equals the slope times m plus the y-intercept. Substitute the slope and the y-intercept into the equation for c of m. This means that after m months, your total cost is $30 times the number of months plus the initial $50. Notice that the slope represents the monthly cost. The y-intercept represents the initial sign-up fee. Together, they form the linear equation that models the total cost over time. In this next example, we'll look at a car rental scenario where the company charges $25 per day, but they offer a $50 discount if you rent the car for a full week. We want to create a linear function to model the total cost, taking into account the discount for rentals longer than a week. Let's break it down. Just like in the first example, we start by defining the variables. D represents the number of days you rent the car, and C of D represents the total cost after D days. The daily rate is $25 per day, so the slope of our function is $25. This represents how much the total cost increases per day. Now, we need to consider the discount that applies after a full week. The company offers a $50 discount if you rent the car for at least 7 days. For rentals shorter than 7 days, the function is simply C of D equals 25D. However, for rentals longer than 7 days, we subtract $50 from the total. So the function becomes C of D equals 25D minus $50 for D that's 7 or more. This means that if you rent the car for more than a week, you get a $50 discount of the total cost. So, our final piecewise linear function is C of D equals 25 times D when D is less than 7, and C of D equals 25 times D minus 50 when D is greater than or equal to 7. For our final example, let's solve a problem similar to what you might see on the test. A landscaping company charges a base fee of $100 for the initial setup and then charges $15 per hour for additional maintenance. We'll write a linear function to model the total cost based on the hours worked and find out how much you'll pay after 8 hours of work. Just like before, let's define the variables. H represents the number of hours worked and C of H represents the total cost after H hours. Our goal is to create a function that gives the total cost based on the number of hours worked and then calculate it for 8 hours. The company charges $15 per hour for maintenance, so this is the slope of our linear function. The slope tells us how much the cost increases for each additional hour worked. The company also charges a one-time base fee of $100 for the initial setup, which is the cost when no hours have been worked. This is our y-intercept, because it's the starting value of the total cost when h is equal to 0. Now, we can write the function. The general form of a linear function is C of h equals the slope times h plus the y-intercept. Substitute the slope and y-intercept into the equation give C of h is equal to 15 times h plus $100. Now, let's calculate the total cost for 8 hours of work. Substitute h equals 8 into the equation. Finally, the total cost for 8 hours of work is $220. The correct answer is C, $220. Notice that the slope represents the hourly rate of maintenance, the y-intercept represents the initial setup fee, and together, they form the linear equation that models the total cost for any number of hours. Great job! Let's take a moment to recap the key concepts we've learned today about writing linear functions from verbal descriptions. In each of the examples, we used the same basic process. We started by determining what the variables represent in the context of the problem. The slope is the rate of change, like the cost per month, day, or hour. This is the starting value, such as the initial sign-up, base, or one-time setup fee. We used the general form of a linear function c of x equals slope times x plus the y-intercept and substituted the specific values. Finally, we substituted a specific value into the equation to find the total cost or result after a certain period. These examples show us how linear functions apply to everyday situations, whether you're signing up for a membership, renting a car, or hiring a service. Once you know how to identify the slope and y-intercept, you can model the situation with ease. Remember, the slope is the rate of change, the y-intercept is the starting value, and together they form a linear function that models real-world scenarios. Keep practicing, and soon you'll be able to write linear functions from verbal descriptions without hesitation. Good luck!